We're solving problem 13 from the 2026 AIME 1. For each non-negative r less than 502, define this, where 10,000 choose n is defined to be 0 when n is greater than 10,000. That is, S sub r is the sum of all the binomial coefficients of the form 10,000 choose k, for which 0 is less than or equal to k is less than or equal to 10,000, and k minus r is a multiple of 502. Find the number of integers in the list s sub 0, s sub 1, s sub 2, all the way to s sub 501 that are multiples of the prime number 503. So basically, from this, we are given that this is true. 1 plus x to the power of 10,000 is equal to the sum of k equals 0 to 10,000 of 10,000 choose k times x to the power of k. Now, for this case, we know that to sum our values, we need k is congruent to r mod 502. So we use x to the power of 502 equals 1. Therefore, we'll also come to this later, but it's good to note that, it's good to note for this. This is what, 503. My bad. But what we can do here is essentially we know 1 plus x to the power of 10,000 is the sum s0 plus s1x plus s2x squared all the way s501 x to the power of 501. Then we can say that if we use this, we have 1 plus x to the power of 503, which is basically just equal to 1 plus x to the power of 503, since it's congruent. And then this just becomes 1 plus x because we use this one. So then what we can do is we can plug this value into this top one, because we know that 1 plus x to the power of 10,000 by using the power rules is 1 plus x to the power of 503 to the power of 19 times 1 plus x to the power of 443. So we know that this right here, 1 plus x to the power of 503, is equal to 1 plus x. So this is equal to 1 plus x on the inside, so 1 plus x to the power of 19 times 1 plus x to the power of 443. So basically, we can just sum these two, 19 and 443, to get 1 plus x to the power of 462. So our sum, or 1 plus x to the power of 10,000, is congruent to 1 plus x times 462. What this then means is that this sum mod 503 is congruent to all this. So we have 1 plus x to the power of 462 is equal to 462 choose 0 plus 462 choose 1 times x plus 462 choose 2 times x squared, and then you do this all the way to 462 choose 462 to the power of x of 462. So then we have the values of, this is the power of 462, right? But it says that we are given all the way to the number 501 for s of sub 501. So therefore, in order to satisfy the problem, we know that this satisfies the values from 463 to 501 satisfy this. So we know that they are multiples of the prime number 503. Then we can find how many numbers are in this group. So we do 501 minus 463, and then you add a 1. This value yields us an answer of 39, which is the answer for this problem. and the number of integers in the list that are multiples of 503.